Let's continue our discussion of probability. This time we're going to look at not theoretical probability, but experimental probability. And as the name suggests, this is based on experimentation. In other words, what we observe to be happening. So the definition of this probability is slightly different. It's the number of successes that we see divided by the number of trials where we tried this event. This may or may not be the same value as the theoretical probability because it's based on something that actually happens. So we observe that there are no defects in 992 out of 1,000 skateboards. What's the probability that the skateboard that we get is defective? Well, the way we do this is we take the number of defective skateboards that we observed, which would be 8, and we divide by 1,000, the total number of skateboards that we looked at. And we would, of course, reduce this, and 8 over 1,000 is 4 over 500, which is 2 over 250, which is 1 over 175. Or you could just take 8 over 1,000, drop it into a calculator, and get the decimal for the probability. Remember, probability is always a number between 0 and 1. It cannot be greater than 1. If you get a number greater than 1, you have made a mistake. Now we're going to look at odds. And odds are slightly different than probability, but they're directly related to probability. Instead of comparing the number of successes to the total number of things that we looked at, we're comparing successes and failures. And there's two kinds of odds. There's odds in favor and there's odds against, and they're reciprocals of each other. So the odds in favor are the number of successes over the number of failures. Odds against would be the number of failures on top, number of successes on the bottom, and these two numbers, the numerator and denominator, have to add up to the number of possible outcomes that there are. So here we go, we're going to example. Our example are what are the odds against rolling doubles on 2 dice. So we have 2 dice. Each dice is numbered 1 through 6, and what we need to look at is we need to look at the sample space. So I ask you to pause and consider how many items are in the sample space when we roll 2 dice. And you should have said 36 total outcomes. Up across the top would be die number 1. These are the possible outcomes for die 1. And down the side we have die number 2. And those are the possible outcomes there. And all of these values in the middle are the possible outcomes when we roll 2 of them. So a 1 on each die, a 1 on die 2, and a 2 on die 1. 1 on die 2, 3 on die 1, and so on and so on. So we're wondering, I forget what we're wondering, let's go back and look. Odds against rolling doubles. So what we need to do is we need to look at how many ways we can get doubles. Doubles mean both values are the same. So how many successes do we have here? There are 6. And if there are 36 things total, how many failures are there? I hope you're saying that there's 30. Now, remember, this is different than what's the probability of not rolling doubles. The probability of not rolling doubles would be 30 out of 36. But the odds against are going to be the number of failures over the number of successes, and reduced, that becomes 5 to 1. With odds, we pretty much always want to give this as a fraction, whether the denominator is 1 or not. we want to say it's 5 to 1. 5 failures for every 1 success. That's what this means. And that's where we leave it. One last comment. Odds can be a number greater than 1. Odds are different than probability. Probability, possible values are 0 to 1. Odds, that's not the case. For example, this one. The odds are 5 to 1. 5 over 1, that's greater than 1. Just wanted to point that out to you before we go any further.